Start.
Hello everyone. The title of our final project is Sequence to Sequence Learning with Neural Networks. We are a team of three and I am Bhuvaneshwari Vallagachu. Coming to the introduction, a question answering system is an artificial intelligence system that provides clear responses to their inquiries. It even analyzes user questions using natural language processing, machine learning, and other cutting edge technologies before retrieving the data from the database or internet and presenting the solution that is understandable by humans. By reducing the time and effort needed to retrieve information, the systems employ a variety of applications. Coming to the approach of our project, there are some steps which includes web scraping the data, creating custom dataset and data loader, generation of tokens using regular expressions, generating vocabulary, and generating dictionaries, creating a mini network from scratch, defining hyperparameters, training the model and model evaluation, and lastly, transfer learning. And the next will be explained by Likit Chaitanya.
Hello all. So we have scraped the data from the Yale University using Beautiful Soup and Request Library. So to show that in the code, let me go to the Jupyter notebook. Yeah, here we have scraped the data from Yale University website using Beautiful Soup and Request Library. And here we created a custom data loader class in which we have using getItem function to retrieve the data from the website that we have scraped. Also, we are generating tokens from regular expression library. Here, we are extracting dates, years, abbreviations, time in EST and PST, money conversions, special words, punctuations, and some of the words that include apostrophes like don't, won't, etc. After that, we are generating vocabulary from the words. Like vocabulary is nothing but the unique words from the words that we have created before. And also we are finding the frequency of each of the words that have occurred in the web page of Yale University. Now we are creating a dictionary of it. Then I'll explain the architecture right away. Here we are taking context. Here we're taking the text and we are embedding the words. There are three types of embeddings: positional embeddings, character embeddings, and word embeddings. After that, in the structured embedding encoder blocks layer, we are placing the positional embeddings on top of word embeddings. On this right side, we are taking a question and also we are generating word embeddings and also we are stacking. From then, we have used multi-head attention in which it maps the question to the respective word. Also, in the embedding layer, it converts word level tokens into a 300-dimensional pre-trained globe embedding vector. Create trainable character embeddings using 2D convolutions. In this stacked model encoder blocks, we are following these steps. A positional embedding is injected into the input. This is subsequently run through several convolutional layers. The layer that these encoder blocks are part of determines how many of these levels there are. After that, the output is sent to a feed-forward network, which is just a linear layer, and lastly, a multi-headed self-attention layer. In left side, we are finding the start index of the paragraph, and in the right side, we are finding the end index of the paragraph, so that to find the total paragraph. This is the model architecture, and the transfer learning and evaluation of the model will be explained by Prasad. This is the code that we have used to do the to implement the model architecture. And also we have created this mini network using all the layers that I've explained before. Now Prasad will explain the results. Here we're creating a mini network. First, there is a class called depth-wise separable convolution in which we are stacking model layer, that is word and positional embeddings. After that, we are creating another class called highway layer in which we're contexting and querying positional embeddings and bringing them to the common point. After that, in this function here, we are weighting the words, that is probabilities. After that, in this create weight matrix, we are initializing random weights for each word. After that, in this embedding layer, we are creating word positional character embeddings that I've told in the architecture of the model. After that, in this multi-head attention layer, we are context and query. We're creating context and query attention. Also, we are finding similarity between two representations and adding the weights, the values in a weight matrix. After that, in this positional encoder block, we are finding the positional and character embeddings as the output. And in this context query attention layer, here we are creating an encoder decoder block wherein we are giving our output and then doing downsampling. After that, we are performing upsampling in the decoder and then getting the output. In encoder block, we are using self-attention, which generate context key query pairs and calculates values.
Transfer learning. We perform transform learning to train the chatbot. The model used here bot for question answering to tokenizer using tokenizer for bot. And we are also giving a few predefined syntaxes for the chatbot to show up when the user begin to ask a question. And conclusion and results. We observe that the accuracy bot is 75% and that of our mini network is 50%. This gap can be covered by changing the hyperparameter of the mini network. This model answer most of questions that is defined in the context. Similarly, multiple questions can be asked and the answer can be retrieved. Thank you.